Bismillahirrahmanirrahim. Indoor air pollution. This is a continuation of our topic of air pollution. The learning objectives for this topic are changes in air at confined rooms, discomfort, indices of thermal comfort, definition of comfort zone, various indoor air pollutants and their health hazards, the standards of ventilation and types of ventilation, and finally methods of disinfection of air. Coming to indoor air pollution, it has occurred since prehistoric times when people moved to live indoors and fire was brought into closed shelters for cooking and space heating. Today, indoor air pollution is not much different from that of the past. However, the problems related to indoor air pollution have developed a new dimension because of newer technology and advanced energy sources as well as tightly constructed buildings. It is a documented fact that human occupancy and activity vitiate air in occupied rooms and give a sense of discomfort to the occupants. The changes in air that take place in confined places are both chemical and physical. Number one, chemical changes. The air becomes progressively contaminated by carbon dioxide and the oxygen content decreases due to metabolic processes. In a mixed gathering comprising all age groups, the per capita output of carbon dioxide is taken as 0.6 cubic feet per hour. This activity may increase up to 2 cubic feet per hour during heavy physical activity. The second type of changes that occur in confined rooms are the physical changes, and it is established now that the physical changes are the most important changes that occur due to human occupancy. Number one, there is rise in temperature. The indoor temperature tends to rise as a result of discharge of body heat. A man at rest gives off approximately 400 British thermal units per hour. 1 British thermal unit is defined as the quantity of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. Under conditions of physical exertion, the heat output may go up to 4,000 British thermal units. Number two, there is increase of humidity. The increase in relative humidity is due to the moisture evaporated from skin and lungs. The expired air contains about 6% of water vapor. An adult at rest releases an average 700 grams of water vapor per 24 hours in the form of perspiration. It has been calculated that a human being releases 18.4 grams of water vapor per hour when sleeping and up to 175 grams of water vapor when engaged in really vigorous exercise. Third type of physical changes is decrease in air movement. In crowded places, the natural movement of air is impeded. Fourth one is body odors. Unpleasant odors arise from foul breath, perspiration, bad oral hygiene, dirty clothes, and other sources. This depends upon the social status, age, personal hygiene of the people in a confined place. The fifth and last of the physical changes is bacterial pollution. The exhaled air contains microorganisms in suspension. These are principally saprophytic bacteria and may include pathogenic bacteria. These organisms are discharged into the air during conversation, coughing, sneezing, and loud talking. Unless vitiated air is replaced by fresh air, it may adversely affect the comfort, health, and efficiency of the occupants. It is known that a feeling of suffocation is experienced by occupants in inefficiently and insufficiently ventilated rooms. Next, we come to the concept of discomfort. Discomfort is a subjective sensation which people experience in ill-ventilated and crowded rooms. For a long time, it was believed to be due to increased carbon dioxide and decreased oxygen content resulting from respiration. However, studies have shown that oxygen content may be reduced to 18% and carbon dioxide content may be raised to over 5% without adverse effects, provided the temperature and humidity are kept satisfactory. So, this theory has since been refuted. It is now established that the causes of discomfort are not due to chemical changes but mainly due to physical changes. These are temperature, humidity, air movement, and heat radiation. These factors determine the cooling power of the air with respect to the human body. It has been so well said that the problems of ventilation are physical, not chemical, cutaneous, not respiratory. Thermal comfort is a complex entity. Much work has been done in the past to determine what constitutes thermal comfort. Several indices have been put forward from time to time to express thermal comfort and heat stress. These are as follows. Number 1, air temperature. For a long time, air temperature was used as an index of thermal comfort, but it was realized that air temperature alone was not an adequate index of thermal comfort. Second is air temperature and humidity. Later, air temperature and humidity were considered together to express thermal comfort. Even this was found to be unsatisfactory. Still later, cooling power was brought as air temperature, humidity, and air movement were considered together and expressed as cooling power of air. An instrument was devised by Hill called Kata thermometer to measure the cooling power. A dry Kata reading of 6 and above and a wet Kata reading of 20 and above were regarded as indices of thermal comfort. Further researches have shown that Kata cooling powers are also not reliable indices of comfort conditions. Next came the effective temperature. Effective temperature is an arbitrary index which combines into a single value the effect of temperature, humidity, and movement of internal air on the sensation of warmth or cold felt by the human body. The numerical value of effective temperature is that of the temperature of still saturated air, which would induce the same sensation of warmth or cold as that experienced in the given conditions. For example, if the environment has an effective temperature value of 30 degrees centigrade, it implies that the subjective sensation of it will be the same as in a saturated atmosphere of 30 degrees centigrade with no air movement. A criticism of the effective temperature scale was given that it ignores the effects of irradiation from the surrounding structures. Shortly after that came the corrected effective temperature. This is an index that is an improvement over the effective temperature index. In this, instead of the dry bulb temperature, the reading of the globe thermometer is used to allow for radiant heat. That is, the corrected effective temperature scales deal with all the four factors, namely air temperature, velocity, humidity, and mean radiant heat. So, whenever a source of radiation is present, it is preferable to take corrected effective temperature. The corrected effective temperature may be readily obtained from prepared nomograms by reference to the globe thermometer temperature, the wet bulb temperature, and air speed. At present, effective temperature and corrected effective temperature scales are widely used as indices of thermal comfort. Another type for indices of thermal comfort is McArdle's maximum allowable sweat rate. McArdle and Associates took 4.5 liters of sweat excreted in 4 hours as the maximum allowable sweat rate compatible with physiological normal reaction of the acclimated healthy young men for repeated exposures to heat. They prepared a chart from which the predicted 4-hour sweat rate can be obtained from any combination of dry and wet bulb temperature of the air, mean radiant air temperature, and air velocity under different work intensity. McArdle has put predicted 4-hour sweat rate value of 3 as upper limit of comfort zone. Now we come to the definition of comfort zone. Comfort zone is defined as the range of effective temperatures over which the majority of adults feel comfortable. There is no unanimous decision on a single zone of comfort for all people, because comfort is quite a complex subjective experience which depends not only on physiological factors but also in psychological factors which are difficult to determine. Considering only the environmental factors, comfortable thermal conditions are those under which a person can maintain normal balance between production and loss of heat at normal body temperature without sweating. Comfort zones used are as below. At the corrected temperature 20 degree, the room will be pleasant and cool. At 20 to 25 degree centigrade of corrected effective temperature, the feeling will be comfortable and cool. The normal values for comfortable comfort zone is 25 to 27 degree centigrade. At 27 to 28 degree, it will be hot and uncomfortable. At 28 and above degree centigrade, it will be extremely hot, and above 30 degree centigrade, it will be intolerably hot. As we said earlier, the comfort zones are the range of effective temperatures over which the majority of adults feel comfortable. So, it is the range of effective temperature from 25 to 27 degrees centigrade over which majority of adults feel comfortable. Next we come to the topic of sources of indoor air pollutants. Indoor air pollution is one of the 4 most critical global environmental problems and probably exposes more people worldwide to important air pollutants than does pollution in outdoor air. It is very important to study the sources and types of indoor air pollutants because comprehensive improvement in indoor air quality may avert acute respiratory infection and chronic respiratory diseases by 15% and of respiratory tract cancer by 10%. Some of the indoor air pollutants and their sources are listed here. This table shows some major air pollutants indoors and their sources. First of all, respirable particles. The sources of respirable particles are tobacco smoke stove and aerosol sprays. Then comes carbon monoxide. It comes from combustion equipment, from stoves and gas heaters. The sources of nitrogen dioxide are gas cookers and cigarette smoke. Similarly, sulfur dioxide comes from coal combustion, while carbon dioxide is a major product of combustion and respiration. Formaldehyde comes from particle board, carpet adhesives and insulation. Other organic vapors like benzene, toluene, etc. The sources of these organic vapors are solvents, adhesives, resin products, aerosol sprays. Ozone comes from electric arcing UV light sources. Radon and daughters come from building material. Asbestos from insulation and fireproofing, and the major sources of mineral fibers are appliances. These indoor air pollutants come with multiple health hazards. The health hazards of indoor air pollution are immediate and delayed, or these are divided into short-term effects and long-term effects. Some of the immediate and short-term effects include irritation of the eyes, nose and throat, headaches, dizziness and fatigue may be observed after a single exposure or may be due to repeated exposures. Symptoms of disease include asthma, hypersensitivity, pneumonitis and humidifier fever, may also show soon after exposure to certain indoor air pollutants. These effects are normally treatable, and sometimes the treatment is simply elimination of the exposure to the pollutant sources, while the long-term effects can be severely weakening or fatal. They include some respiratory diseases, heart disease and cancer. These effects may be observed years after exposure or only after long or repeated episodes of exposure. Next, we come to the topic of ventilation. The ability of an individual to comfortably accommodate himself in a house depends upon many factors in the environment, the most important one being the ventilation provided in his living and working area. Ventilation is defined as the intentional movement of air from outside a building to inside. Adequate ventilation improves comfort levels of an inhabitant. However, excess of ventilation may result in discomfort due to cooling of the indoor air temperature, which is not desirable. The daily requirement of air for a person is about 10 to 20 cubic meters per day. There are some standards for the ventilation. The fixing of standards of ventilation is a matter of much difficulty. Most of the standards of ventilation have been based on the efficiency of ventilation in removing body odor. Let us go through the standards of ventilation in order of importance. The most important one is the floor space. It is the product of length and breadth of room as a parameter of ventilation. Heights in excess of 10 to 12 feet are ineffective from the point of view of ventilation, as the products of respiration tend to accumulate in the lower levels. Therefore, in calculating cubic space requirements, heights over 10 to 12 feet are not taken into account. The optimum floor space requirements per person vary from 50 to 100 feet. Floor space is the product of the length and breadth of the room as a parameter for ventilation. Heights in excess of 10 to 12 feet are ineffective from the point of view of ventilation, as the products of respiration tend to accumulate in the lower levels. Therefore, in calculating cubic space requirements, heights over 10 to 12 feet are not taken into account. The optimum floor space requirements per person vary from 50 to 100 square feet. Second standard of ventilation is air change. It is now established that carbon dioxide theory is not quite correct, because even if carbon dioxide content of air is raised to over 5% and oxygen content is reduced to 18%, there are no deleterious effects so long as cooling power of air was satisfactory. Air change is more important than the cubic space requirement. It is recommended that in living rooms there should be 2 to 3 air changes in 1 hour. In workrooms and assemblies, 4 to 6 air changes are required. If the air is changed more frequently than 6 times in 1 hour, it is likely to produce a drought which should be avoided. Third standard of ventilation is cubic space. Current standards consider 1000 to 1200 cubic feet per person per hour to be sufficient for generating comfort.